afternoon to everybody dialing in from India, and good morning to everybody listening in from Germany or Europe. Welcome to this panel discussion on green buildings for today's cities at the Indo-German Forum on climate and cities. My name is Sima Isar, and I'm working with the German Sustainable Building Council, and I will be chairing today's session. Before we go on and talk about the potential buildings have to make our cities resilient, I'd just like to take the time to point out a few technical housekeeping things to our audience. You have the opportunity to pose your questions to the panelists, so feel free to pose your questions through the chat function. I will try to incorporate your questions into the discussion. Today we have joining three panelists, three building experts. We have Professor Dr. Werner Lang from the Technical University in Munich. We have Dr. Dirk Schwede from the HFT in Stuttgart. And we have Dr. Ashok Kumar from the CSIR CBRI Roorkee. But before we go on and talk about have our keynote speeches from our experts, when we think of cities and buildings, what comes to our mind? Buildings give our cities, give the cities we live in a landmark and make our cities recognizable. Buildings and cities are also the place where we spend the majority of our time. Just think, you yourself, how much time do you actually spend indoors? So buildings actually give our surroundings an identity. But then obviously there must also be a flip side to buildings, because otherwise we would not be talking 90 minutes today on green buildings and cities and climate. Because currently buildings account for around 40% of the carbon emissions worldwide. And additionally, we have the growing population, we have global warming, and we have dwindling of resources, which additionally are putting pressure to make us have to rethink of how we are building our buildings today. So from my point of view, we are standing at crossroads today because it is clear that we need change in the way we are constructing our buildings today. Professor Dr. Lang, who is working at the Technical University of Munich and is a professor for energy efficient and sustainable building and planning, has been researching energy efficient buildings and looking into ways to optimize the building envelope. In his research, he is also looking into reducing the building's fossil fuel requirements and how to use more renewable energy on site. This makes him the ideal speaker for our first keynote speech this morning, and showing how buildings, or if buildings, have the potential to have a positive ecological footprint. So I hand over to you, Professor Lang, and you have 15 minutes.
Well, thank you very much. Good morning, everybody. It's a real pleasure and an honor to speak here. So thank you very much for the invitation and also for the kind introduction. If we move already to the first slide, basically you will see building with a positive footprint as my title. Is it utopia or is it reality? When I say building with a positive footprint, I will address that issue in a second. So here, I think today with this presentation, I'm trying to show that just becoming a little bit more efficient, let's say reducing carbon emissions by whatever X%, reducing resource consumption by whatever X% is not really enough. We are really, like you just said, Sima, we are really on a kind of a threshold where we make the decision whether we are looking forward to a future for mankind or not. It's absolutely serious. And of course, we have to create, with all this seriousness, we have to create a positive image. We have to show solutions to the people, because just complaining how bad the world is and how bad the situation is not changing the way we are going. So we really need this kind of examples of positive buildings which have a positive ecological footprint. And I can already answer, it must not be an utopia, but it has to become reality. So the way this presentation is structured, I will talk very briefly about climate change and global growth. an issue which just has been addressed briefly by Sema. Then I will address the issue of climate change and building, also very briefly, because I'm assuming that there's a lot of experts in this field already in the auditorium. Then, of course, that's what I said before, the strategies become very important, how to really fight climate change. And then the main part of the lecture will be really on building with a positive ecological footprint. So when we look at climate change and global growth, what we see here is basically a chart. Some of you might know the global carbon budget. And I think for quite a few people, it's always very difficult to understand what we are doing basically as mankind. And this chart, and if you look at the figures on the right, the numbers you can see there, is very simple to understand in the way, because we have on the one hand our total emissions of mankind, which is roughly 40 gigatons of CO2 per year. So it's 40 trillion basically gigatons per year. Then we have the total sinks. That's the ability of our planet, the green organisms, if you want to call trees and plants and algae in the sea organisms in a way. It's the plants, so to say, which are absorbing our CO2, which can absorb part of that CO2 also permanently. So the sink basically is about 21.7 gigatons. So it's roughly 40 against 20 or 22, if you want to be more precise. That leaves us with roughly 18 gigatons of CO2 we're adding to the atmosphere each year. So that's not like going up and down, because there's a difference between summer and winter. There's leaves on the trees and not. But these 19 or 20 gigatons, which we are really blowing into the atmosphere in addition to what nature can absorb, is really adding to the concentration of CO2. So if we take the sinks, these 22 gigatons, and divide that by the world population, we are actually getting the figure we would be allowed to emit, because that's the amount of CO2 which nature can absorb, whether it's the land or whether it's the sea. In the sea, there's algae. On the land, there's a lot of plants, trees, grass, whatever, which are absorbing and storing basically the CO2 in their roots, in the timber, and in the physical appearance. So that's the goal. I mean, that's basically when we want to stop CO2 emissions, we will not need to stop them completely, but it has to stay within this kind of absorption ability of our planet, of nature. So, but today that's the conflict we are facing. We have an average of about 5.2 tons of CO2 emissions per capita, per person, per year. If we look at basically at other countries, if you look at our own country here in Germany, where I'm coming from, we are currently emitting a total of 11.6 tons per person and year. So we are twice as much, we have twice as much emissions as allowed. Heating, basically the building sector, is responsible for about 1.7 tons. Then we have the electricity consumption of our buildings. Mobility comes also into play. Food, general consumption, and public emissions through infrastructure. That's basically the split of the CO2 emissions we have. But the main thing here is that the goal is 2.8. The global emissions are 5.2 on average. We are far too high. So actually, you have to really take my word in a very critical way, because coming from Germany, I'm part of that, right? So we have, as the developed world, we have a huge burden we have to solve, basically. And if we just compare that to India, where we have roughly about 2 tons per capita, so you're staying below basically the allowed average. So you should be acting more as a role model when it comes to CO2 emissions, but because there's, on the other hand, also an increasing demand for increasing the lifestyle, increasing health, increasing education. So we have to find this balance of well-being on the one hand and staying within the planetary boundaries. Kate Raworth would call it basically the donut economy, or we could call it a bio-based economy in a way. So that's where really have to go. Bio means that's the capacity of our nature to absorb CO2 permanently, right? And that's what the role model for our action should be in the near future. So when we look at the next slide, climate change and building, that's what Seema said already. So building related emissions are about 1/3. So we as architects, as politicians, as planners, we cannot point fingers to the others, but because it's really us who can make a change. It's us who can solve this 1/3 at least, where we have to go to zero. And actually that's what we are bound already by the EU laws, by the latest directive. We have to build from this year onwards, from 2021 onwards, every building has to be nearly zero carbon. Nearly means without adding a little bit of, let's say, photovoltaics or thermal collectors. We are below that goal. The moment we are putting then PV cells on our roofs or use thermal collectors or both, we should be really, or we must be really carbon neutral. That's, let's say that's the law, that's the directive. Reality, of course, is still different. And that's also including not only CO2, but that's also including the resource consumption. That means materials. So we are depleting the resources on our planet. We're taking out of the ground materials, not only fossil fuels, random or seldom earth, lithium as an example for producing batteries and so on. So we are just taking for granted that whatever we have in the soil embedded, it's ours, whether it's minerals or any other kind of important substances. So that's already a flaw. That's already a fault, where we just buy a piece of land and we feel entitled to take whatever is down in the ground to use that for us, for our own benefit, for our own business model. So we have to change that also. We have to change the business models. And when we then look basically also into other aspects, whether it's water consumption, which is very scarce in large parts of this planet, large part of our global population is suffering. So we also have to look into that tremendously important in an important way. And then the last point, not the least one for sure, is global waste generation by the building trade is 40% as an average globally. Here in Germany, it's 52%. So more than half of all the waste we're producing in Germany is related to the building sector. So it becomes clear that we have to change that real quickly. So what are the strategies? The strategies we are running in Germany is still based on efficiency and to some extent also on consistency, meaning the use of renewable energies instead of fossil fuels. Of course, this policy of focusing on efficiency, I think it's okay. It's important to do that. But if you look basically at this chart, you know, where we are standing right now, the last column in orange, that's the situation we are still having today. We are far from reaching the reduction goal. You see the red columns basically, that's showing where we must be by 2050. And since we are already in the year 21, we are not right now with the policies we are having, we are not nearly getting where we are supposed to be. So this radical change is absolutely necessary. To this search for alternative business models is absolutely key to achieve that. And so efficiency alone and a little bit of renewable energies is far from being enough for achieving the goal of carbon neutrality by 2050. So in addition to the efficiency I've mentioned, doing the same with less effort, you know, becoming more efficient with energy consumption and CO2 emissions, where we have to go really to zero. That's the thing here, not by 10%, 20%, but really moving towards zero. This has to be coupled with consistency, a fundamental different approach. Instead of non-renewable energies towards renewable energies, instead of non-renewable materials to 100% renewable materials. And where we cannot achieve that, to introduce circularity as a major aspect. And the third point, which is hardly discussed in public, is sufficiency, where we have to really ask ourselves, do we really need all the stuff we're having around here, at least in our culture, where we are filling attics and basements with stuff we don't need in our life? So the less living space is an issue here. And the question that we have to ask ourselves, whether life with less stuff is not even more fulfilling than to constantly consume, throw things away and consume, put it on the attic or in the basement, complain about that our apartments are full with stuff. So sufficiency is really an important aspect. So in the end, where we have to go to with our energy consumption is leaving this kind of negative approach, the blue part, the building practice, where we are still moving to less CO2 emissions, to really turn the whole thing around, the thinking around towards a positive thinking. So are we able to achieve principles like building with a positive footprint? That's here a question where we basically look into the implementation of a positive ecological footprint in construction through the increase of resource efficiency. So fine with efficiency, let's still keep that on our mind. Let's still keep that as a major principle, of course, but then we have to really look into regenerative energy systems, into regenerative construction materials, like I said before, and also into the implementation of closed loop economy. So that will give us the chance really to go towards energy positive building. And we have done that already. Werner Sobeck is one of the first ones who has won a public federal competition on an Energy Plus house quite a long time ago already. It's still in place in Berlin. Beautiful architecture, a very good example. We have done a similar example more to market value. An experimental building is very expensive. We try to really stay within the economic limits of single family homes, which of course is questionable as a principle here in Germany. We have to use multi-story buildings instead of single family home. But for the time being, we use this example to really show that, let's say, with a really good thermal insulation and with photovoltaics on the roof and heat recovery systems and use of geothermal energy, we can really get there. You see the simple principles there. We have a highly insulated building there with photovoltaics there as one of the principles. A heat pump system, which is coupled with a very kind of shallow geothermal energy. So it's not like 100 meters down in the ground, but just a few meters, in order to use the temperatures below ground, which are staying the same most of the year, basically, to have a certain energy level we can use for heating in summertime, but also for cooling in wintertime. And the coupling of the energy systems, the coupling with thermal energy storage, where we only for this building, for instance, used 4 cubic meters of water to balance temperatures. Very simple, very easy, very inexpensive. And of course, with also batteries, which are not really that extensive. Basically more in the range of 6 kilowatt hours of storage capacity. If compared to a car, there we are starting right now with modern cars with 36 kilowatt hours. So that's very, very important. So that's an example just to show you it can be done. This has been implemented like you saw before. And the second very important topic is really circularity, where we show what we're doing with the material. So this is a building which has done basically with students in Austin for the Solar Decathlon 2015. We were part of that from the side of the Technical University in Munich. Since I taught at the University of Texas before, we did that with a colleague of mine, and we showed that with recycled material and the process of designing for disassembly, for joints which can be open for the construction, we really managed to do a building which is fulfilling the Energy Plus aspect, where we're also running a car with the additional energy we are generating, plus in addition to what we need in the house. And we have designed it basically in such a way. So I hope that the animation now works here. Let's see. And the same after the competition, went back then to the desert setting in Texas for a research facility where we now have guest scientists living in that building. So just showing that it can be done, it can be even done with students with using renewable energies, a fully recyclable building, which could be used anytime at any location, where the design for the climate is done in a similar way in the future. So we have to keep these buildings in a complete circle. So coming to the conclusion and also bringing basically the whole concept into an urban environment. So on a building level, we really have to look into ways, we must look into ways to couple efficiency, consistency, and sufficiency. The building materials have to be kept in a complete circulation. Buildings must act as raw materials, like warehouses almost, for future construction projects. So if you're interested in that, you have to look into BAMB, European Research Project, BAMB, Buildings as Material Banks, a large research project focusing on that, where we have been part of it. And the life cycle assessment, where we're looking into the whole life cycle, has to be the base of our design. So when we look into a city, on a city level, we have to use these buildings, these green buildings, so to say, as a base. But in addition to resource and energy flows on the top left here in this graph in green, we have to look into green infrastructure. We have also a Center for Climate Change and Climate Change Adaptation, where green infrastructure plays a major role, where the cooling capabilities of a tree has to be taken seriously in addition to shading, to shade our buildings and create comfortable outdoor space, really important aspects. We have to use thermal insulation and eco-balancing as tools in order to achieve that. And we have to look into the whole interdependencies of these different systems to optimize the overall system city, to optimize the overall system building, looking in all these aspects as part of the life cycle analysis. Thank you very much. Thank you very much for the attention. Thanks a lot.
Thank you, Professor Lang, for this very interesting insights on how, and these case studies on how you can integrate circularity and renewable energies into our buildings. Next, we will have, so we now actually know what 2050 should look like. Let's hear from Dr. Dirk Schwede, who is working at the as a research group leader for system integration and sustainable buildings at the Institute for Building Energetics. And he has focused his research on several sustainable development projects in the Asian context and also in the Asian climate, as well as looking into adapted sustainable building approaches in Vietnam and Cambodia. And let's hear what the necessary roadmap to 2050 must look like.
Good morning to Germany and good afternoon to India. I would like to introduce some of our projects which we have conducted and which we are currently conducting in the context of several Asian countries. And I would like to talk about our project in Vietnam and also a short introduction to our project in Cambodia at the moment. We are dealing with sustainable urban development, and my research group at the University of Stuttgart on systems integration and sustainable building is especially focusing on the aspects of buildings. And you can see our, this is context which was introduced by Professor Lang already. We all know that the building sector is responsible for a large part of the energy consumption, about 30 to 40%. And this is the same in many countries around the world. And related to that, of course, the building and construction sector, the building sector is responsible for carbon emissions of about 40%. When we look at this we add, and Professor Lang has talked about it already, that the construction sector is also responsible for resource consumption and in relation to that also to waste generation. This is all describing the problem we are facing, and the problems are similar in many places around the world. But of course, the context where we start and which we find to solve these problems are different in the different places. What is also important, not talking so much about the problem, but it could be a problem, but it could also be a contribution to the solution, is that the construction sector is also a great part of the economy. And that, of course, poses a lot of danger to sustainable development, but it also creates a lot of chances, a lot of opportunities, because the construction sector, of course, it does a lot of harm to the environment, to sustainable development, but it can also be understood as a chance, as an opportunity, as a business opportunity, opportunity to develop countries. For example, when cities are built and there's a lot of urbanization going on, there is a lot of need for construction. There is a lot of need for materials, and so on. And that poses not only the threat, but also opportunities to do it better from the beginning. And now what is even more important, almost 100% of the people live in the constructed environment, live in the built environment. And that means that we not only talk about the problems, the emissions, energy consumption, resource consumption, and the economy, but we talk about the people in the city, in the buildings. And then we have to talk about quality of life. And we can also connect to the topic of what Professor Lang introduced, the sufficiency issue, that what people are satisfied with, and how can we create quality of life perhaps without using so much resources. And this is something we would like to investigate in our projects. And another thing which we found in our projects is that we have different starting conditions. This one is now a picture from a project I'm currently doing with the Asian Development Bank in Ulaanbaatar. They have a very big problem with air pollution and with the quality of the urban environment. But they at the same time, they have a very interesting and very ambitious vision of how they want to be in the year 2040 or 2050. They have a master plan with a vision, and this vision could be used in many cities, in many countries around the world. It's always the same. We want to have a sustainable city. We want to have a vibrant city, resilient city, and we want to have a smart city, efficient city, and so on. But the question is, how do we get from the situation we have today, a lot of energy consumption, a lot of pollution, to the situation we want to have? And by that, there we have to address topics like improved air quality, energy efficiency, clean energy, resource efficiency, waste management, traffic, urban green, and many other topics. It's a very complex issue. And this is why there is now the movement towards creating roadmaps. And there is an initiative by UNEP supported by GIZ, which is developing roadmaps for regions, but then also for different countries and perhaps for single cities. And in these roadmaps, we have to define what are the steps. And here I brought some examples. For example, the greening of the energy mix. That is a task which we have to fulfill all around the world, from the fossil fuel-based energy mix over some steps to a green energy supply. And we can't do it in one step, and we can't do it without planned steps, but there need to be some roadmap, and we need to take the time to do it with some strategy. And the same is also for the development of the key technologies. The key technologies are, of course, sustainable materials, so that we can build energy efficient buildings, sustainable energy systems here, for example, air conditioning system. And we know where we come from, but we also go to and what we can achieve in future, because most of these technologies we need around the world are already there. They are in laboratories, and they are in some countries already in the market. So we know where we want to go. We know where we come from, but we need the steps in between. But because no country can just jump from one to the other. And then we, of course, need to develop policies and also research and development initiatives, perhaps from a prescriptive building code to a more performance-based building code, as it at the moment happens in many places around the world. On the building level, this is also very important that we don't run into lock-in effects. It might be in some countries that it's not the right time yet to build plus energy buildings or to build buildings with building integrated photovoltaics. But we have to make sure that we can retrofit these technologies, that we can improve the buildings we have to build today for the people. We can improve them to be sustainable in future, because no economy or most economies cannot do this in one step. So we have to have this target in our view and have to understand which steps are necessary to get there. And then we have to start and walk in the right direction. At the moment in the European Union, we have refurbishment roadmaps for building projects where building owners have to define which steps they want to go towards carbon neutrality. And they don't have to implement it in one go, but they can implement it in steps. And this is very important. And now I want to talk about our projects in Vietnam. Here is the Kamasek project, the Climate Adapted Material Research project in the social economic context in Vietnam. It's funded by the German Ministry of Education and Research within the FONA program. And here our research aim, the objective is to build research facilities which are needed to provide the knowledge for the application of the new energy standard. There is a new energy standard introduced, but the market, the industry says we can't use this standard because we don't have the materials, we don't know how the materials perform. And so we need to build up testing facilities to characterize simple materials. How is the heat conductivity? What performance do these materials have? And then also how the impact of the material is in the life cycle. And there is a movement from burnt bricks, which consume a lot of energy, which consume a lot of resources, towards more resource efficient materials. So in this project, we are doing also life cycle assessment studies and so on. And we find that the researchers in our partner universities are good partners to discuss with and to introduce these topics. What we also do is we develop climate data sets so that the energy consumption can be modeled and can be simulated. And we integrate, of course, the effects of climate change, because in the last 10 years, in the last 30 years, the temperatures rose. So we need new up-to-date climate data sets to do our analysis of buildings in order to plan energy efficient buildings there. We also do measurement in buildings so that we understand how the apartments are used and how they are operated, because we know from the past and also from our experience in Vietnam, in China and other places, that the people using the buildings and their apartments very sufficient. So they don't condition the spaces, they don't heat the spaces too much, but they adapt to the environment. But this behavior is changing. The people want to have a higher quality of life, so controlled temperatures are coming, and with that the energy consumption is rising. And with this, in our project, we determine information on the indoor climate. What we also do is what I talked about before. Here we work together with the Fraunhofer Institute for Building Physics in Munich and in Stuttgart. We build up laboratory equipment and laboratories at the Vietnamese Institute for Building Materials, where then the materials can be characterized so that the market has the information it needs to build energy efficient buildings. This is what we do at the moment in our project Kamasek, Climate Adapted Material Research in the social economic context in Vietnam. So we connect many different areas, but develop technical background for the application of energy efficient and sustainable buildings. We have another project in Cambodia. This is a Build for People project, very much focused on urban quality of life. Here we have different work package. We work together with environmental psychologists who look at how people live, what are the desires, what are their aims, their objectives in life. And then we have the work package on sustainable building, where we look how can that be implemented in the building structures. We have a work package then on sustainable urban neighborhoods, which is of course related to the buildings. The buildings are constructed in the neighborhoods and there is some interaction. The outdoor spaces are very important. So we have also someone who is looking at urban green and how urban green can be improved in the city, looking at urban climate. Here, this is also very important. There's modeling done, how the temperatures are in the city. And we have, of course, a work package which is looking at urban transformation, where we look how does this relate to the policy framework and what can be done in the policy framework to move all these topics forward. Yeah, this is also a long-term process. We just start this research project for the next 4 years and hope that we can continue then afterwards also with the implementation phase. Now the research and development phase is starting, so we have a long-term approach here, and we will do a lot of workshops to understand what is the condition in Cambodia, in Phnom Penh, and how can we work together with the local stakeholders to improve the situation or to make suggestions for that. Altogether, I would like to summarize that, let's say, the roadmap to 2050 towards climate neutrality is not so easy. It's to talk about and to achieve green buildings for tomorrow's cities. We need to be thoughtful and need to do steps today. We need to be strategic and we need to be aware that we can't really do it in one go and one step, but that there are single steps to be done. A climate neutral building stock needs a local approach and a concerted action of many layers of politics, economy, and society, and also a reliable policy framework which we can set up in a roadmap can create business opportunities. It gives security for the market stakeholders, and that is very important to achieve the goals. And then, of course, we are here on a research conference. Research and international exchange is needed and supportive, but we have everywhere different starting points. We have a common vision, but we have different starting points. So the research must focus on understanding the starting point condition in order to move forward in the right direction, but with a locally adapted approach. Thank you very much. I hope we can continue with the discussion after the presentations. Thank you.
Our next keynote speaker would be Dr. Ashok Kumar, who is currently working at the Central Building Research Institute in Roorkee. Dr. Ashok has over 31 years of experience in this field and has been teaching as a visiting faculty for the past 12 years. In his research, he has been mainly focusing on building energy efficiency and energy efficient building technologies for retrofitting. Dr. Ashok Kumar, the next 15 minutes are yours. I think we can maybe just continue with the discussion, and in the background we'll try to get Dr. Ashok Kumar back into the line. We've actually already had one question for you, Dr. Schwede. How do you use energy plus weather data for your analysis? Maybe you can just elaborate a little, and we'll try to get Ashok Kumar back.
Now I'm talking again. Yes, thank you for the question. We don't actually use energy plus weather data because for Vietnam, there is not too much weather data. So we bought ERA 5 weather data from the Copernicus program, and we created own weather data sets. And these weather data sets, we got raw data of the last 30 years. This is simulated data also based on measurements. So they do measurements and then they simulate the missing parts and make it more consistent. And we use this data to create reference data sets for thermal simulation and also for hygrothermic simulation, so that we can use Energy Plus and Transys, but also programs like WUFI, like for hygrothermic simulations. So these are new data sets, and we will publish them in the context of our project for Vietnam.
As we're talking about weather scenarios, maybe it would be also interesting. In India, the majority of cities actually lie on or are built on the coast. So when we're looking into green buildings, it will be necessary to also look into how our buildings can adapt to future climate scenarios. Maybe Professor Lang or Dr. Swede, one of you can elaborate how can green buildings help in coping with either heat waves or flooding, and how can green buildings help in cities' climate change adaptation strategies?
Yeah.
Yeah.
So we answer now, or do we continue with Mr. Kumar?
We can continue with Dr. Kumar, and then we'll come back to the question later.
Good afternoon from India, and good morning to people in Germany. So the earlier speakers have already covered a few insights on buildings with positive ecological footprint, and also a roadmap to 2050 necessary steps towards climate neutrality. So this makes my job simpler, where I will be covering some details on the innovative approaches for green and energy efficient buildings, where in the sequence of presentation is wherein I will be giving you some background on the planet Earth issues and challenges, and some insights on green and energy efficient building technologies, and some innovative approaches for green and energy efficient buildings by giving some examples on the research projects that we have carried out at the CSIR Central Building Research Institute, Roorkee. Right. So if you see the challenges in the background, we have the climate change, energy shortage, urbanization, and infrastructure. So all these challenges are, bothering the entire world, and the designers, architects, planners, scientists are, trying to come out with solutions to these challenges. And I think green and energy efficient buildings and technologies are one of the solutions to overcome these challenges. And if you see the climate action tracker, we are concerned about, if you see the line over here, where you can see the perspectives, the scenario at say March 2021, where the temperature is at 1.1 degrees Celsius higher. So that means we need to develop policies at the global level, and some countries have already taken initiatives to come out with policy roadmap to address these issues. And if I talk about the another challenge that we have is that the planet Earth has a finite size, and we also have limited resources. And if you see on the other side, humans is using more than 1.6 times the amount of resources that we have. And the Earth Overshoot Day, which fell on 27th of August 2020 last year, and it was 3 weeks later than 2019. But due to this COVID-19 pandemic, ecological footprint was lessened, and shifting the resource consumption patterns in a short time frame, which was possible due to a pandemic. So if you see the definition of Earth Overshoot Day, which marks the day when humanity's demand for ecological resources and services in a given year exceeds what the Earth can regenerate in that year. So that means sustainability that allows us to drive or to thrive on Earth. This can be achieved by research, planning, and design and not by disaster. So we need to be very, very careful in that. Where is the world going? If you see the RIBA guidelines or the current benchmark and the 2020 targets, 2025 targets and 2030 targets, wherein starting from our operational energy of moderate carbon and potable water use, you see these scenarios are developing, and India commits to net zero emission by 2050, and several initiatives are underway. And why we are concerned about buildings? Because approximately 40% of the energy use is there in the buildings, and approximately 17% of potable water consumption, about 25% of wood consumption, about 55% of the natural gas use, about 30% of the waste generation, and as rightly mentioned by Professor Lang, that about 40% of CO2 emissions. And so that means we need to find some solutions to these challenges that are bothering all across the world. So green building as one of the solutions, it defines that a high performance building designed, constructed and capable of being operated in a manner that increases environmental performance and economic value over time. Although they look similar, but there are differences in operational savings in the investment, saving in the overall resource efficiency, and providing better human comfort and productivity. And although the overall cost may increase to 5 to 30%, but the payback period is around 3 to 6 years, right? And based on this, why we need so-called green buildings? That means to save the emission, that is the single point agenda, to create less impact on the planet in terms of energy usage, carbon emissions and carbon footprint. Already Dr. Lang has mentioned. So that means we must be able to quantify how much building is consuming, what time, what levels of emission is it doing. Everything is in numbers. If there is no quantification, what can the prescription help in? So that means we need to quantify each and every component of that. If I talk about the fundamentals of green design, we have to consider several components, starting from energy, water, materials, adaptation, waste and pollution, health and comfort, ecology, community, management, planning, design and processes. And in my talk, I'm focusing mainly on energy, materials and planning and design processes, where the focus is on concerns, considerations, implications and the context. Context means majorly the Indian context I'm talking about, right? And some example of green buildings, I'm not going to discuss this, but because I will be speaking more on the quantification. But I'm afraid to say that these are not the green buildings we are looking at to take care of the emissions and to take care of the load which is putting in these buildings. These buildings are both an oven and a refrigerator in extreme weather conditions, having say more than 80% of glass. So what are we doing? So that means if you talk about fundamentals of green design and particularly the energy concerns, so we have to minimize the demand, we have to minimize the efficiency, or maximize the efficiency, and strategize the resources so that the building is planned in an efficient manner, and also this will lead to a reduction in the greenhouse gas emissions. So how it is possible? By deploying considerations like all these building physics principles, like we have to develop an appropriate or efficient form, shape, occupant behavior, orientation, and all of design for daylight, with window to wall ratio, natural ventilation, reduction in cooling and lighting demand, and cool roofs, and many other parameters, both in terms of passive as well as building physics principle. And implications means important outcomes. Designing for energy means lowering the operational cost, and also doing better energy savings and lowering the greenhouse gas emissions. So these are concerns and considerations, and also the important points which I mentioned are very much required to take care of the implications and the context is India. So, as I mentioned, there are several initiatives that India has taken. The one such initiative is India's Cooling Action Plan, where this is focused on finding solutions and reducing the use of air conditioning demand by about 25% and about 30% reduction in the refrigerant demand over the next 20 years. So that means there is a need to quantify the thermal load reduction and also quantify the refrigerant use by adopting or deploying several measures, and it can be demonstrated. Yes, it is possible. So if I give an example about the building energy efficiency, where there are three parameters which we always consider in the design of buildings, whether it's a heat dissipation or the other parameters which are essentially required, heat protection strategies or natural resource optimization strategies, or the heat dissipation strategies, starting from your controlling the microclimate and the solar control or the renewable energy usage, and also taking care of the daylighting, thermal mass, and the insulation and passive cooling measures. We can the question is, can we quantify the impact of these parameters? The answer is yes, and I will give you some examples. As I mentioned, there's a energy conservation building code in India which prescribes the following three levels of energy efficiency. That is ECVC building, ECVC plus building, and super ECVC building, which prescribes different U factor, overall heat transfer coefficient values for roof assembly and the walling assembly and the glazing. So you can depending upon the thermal conductivity of the material, you can determine the U value, U factor for different kinds of materials. So we at CBRI have computed the thermal conductivity of over 300 types of materials, and we have developed a program in the BAT Lab program, and there are around 300 combinations, and where we can quantify, and it will serve the purpose. So that means everything must be quantifiable, measurable, and verifiable. So that also quantifiable means by adopting there are several simulation tools which are available in the market, and which can be deployed in the right from our early design stage as an architect. So if I talk about the first part, which is the in the concept design stage, you can as I mentioned earlier, we can optimize the form, shape, AVI-V ratio and things like that, and go to the next part, which is the building level, and at the construction level, you can all these considerations can be deployed. And I'll give you some example where we have used these concepts. As I mentioned, the first principle is to adopt building physics as one of the most important, or the prerequisite for climate responsiveness and insulation on ground, which does not exist in many codes, and architecture must be climate dependent and not copied from somewhere to suit its agenda, right? And yes, as I mentioned, we can reduce the thermal load by decoupling the structure from the climate, and it has to be a single microclimate, or rather a microorganism, and all measurements can be quantified. That we have done a study where if I give you one example, this is a single unit where this single unit receives the least heat gain and no fenestration. But if this unit is grouped into a cluster, a block of 4, linear form, longest exposed wall has maximum fenestration, there is a maximum heat gain. Similarly, if this single unit is clustered into this one unit, second, third, and fourth, with a staircase in between, the square form exposed wall has no fenestration, and the heat gain through the opening is minimum. So that means keeping a square or a rectangular build form is always a better option, which will have least amount of heat gains and is more energy efficient as compared to your longer L shape or T shape. And we can quantify the impact of material on thermal efficiency as well, as we have done. Right?
Kumar? Maybe close your presentation in the next minute, please, so that we can move on to the panel discussion.
We have done some study on real-time models where we have done the experimental studies to quantify the impact of several parameters like effect of window to wall ratio, orientation, story height, roof, wall insulation, and around 300 combinations we have adopted, and based on these simulations, we have tried to utilize this knowledge into demo buildings. There are 2 identical buildings, and test beds have been created by doing all this interventions, and by adopting these 6 interventions, we are getting energy savings of the order of 34%. Right. So this is very, very essential, and material part I will be leaving, and but I can give one example on life cycle energy, which the earlier speaker was talking, Dr. Dirk, and we have done a study on life cycle energy where we have developed an Android app using these equations, and there are several background calculations done on embodied energy and operational energy and demolition energy, and these equations have been used to compute the life cycle energy assessment of a building located in Roorkee, India, and where this is the operational energy of a house, and we have computed the building for 70 to 75 to 100 years, and selecting the Android app, selecting the life cycle of the building, then select the climate that India is divided into 5 climatic zones, and select the area of the building, and you select the foundation type, you select the walling type, you select the roofing type, and all these you can select, and at the end of the day you can get the final results. That means the operational saving around 82%, embodied energy initially is 6.7%, and embodied energy recurring as 1.3%. So like that, you can compute the life cycle energy of any building. So that is very, very essential, and the work. And finally, what we are doing is taking the learnings from all these test beds and the basic research work that we have done. We are currently demonstrating a net zero energy building where everything is quantifiable, measurable, and verifiable, and where building physics principles and the materials which are developed at CSIR, CBRI, and other CSIR laboratories, and also integrating solar and geothermal hybridization, where we are targeting that it's going to be net zero and also zero carbon building. So this is in brief, and to conclude, I can say that building energy efficiency can be improved, and we have to reduce the consumption. We have to use the correct technology for exchange. We have to supply from nature. We have to reduce the refrigerant. We have to reduce the energy consumption and low carbon emissions. And finally, this is the profile of our institute, Central Building Research Institute, established in the year 1947, where we, under one roof, we have all these disciplines, starting from architectural planning, building energy efficiency, materials and building processes, structures and foundation, fire hazards, and disaster mitigation. So with this, I thank you for your patient listening, and deep regards to our Director General CSIR, Director and staff of Central Building Research Institute, Roorkee, India, Indo-US Science and Technology Forum, and Department of Science and Technology for sponsoring some of these studies to CBRI. Thank you very much for your patient listening. Over to Ms. Seema.
Thank you very much. I hope, thank you very much for your presentation. I think we've had really interesting insights into how the roadmap to 2050 must look like, energy efficiency, and now we've already got the first few questions coming in from the audience. I'll just start with those so that we can make sure that the audience questions are answered. So one question is, how are we planning to scale up and pace the deployment of complex green technologies for homes in developing countries? The participants see here a lot of hurdles, for example, lack of investment, innovation, poor implementation, and lack of knowledge. Perhaps, Dr. Ashok Kumar, you can point out how we could scale out or scale up these green technologies in developing countries.
Very, very important question, how we can scale up the different technologies. Already, the attempts are going on, and there is a focus that, industry should come forward, and there has to be industry research interface, and not only industry research interface, but industry, academia, and research interface, so that, there is a synergy between all these three, and once there is synergy, definitely, the technologies can be taken further. Number one. Second effort is, we always, impart trainings to different people across the country, or even outside the country, different stakeholders, starting from the students of architecture and engineering, and on one side, and on the other side, the people who are in the field, who are, using these technologies and implementing these technologies. So all that, whatever is generated at the lab level, we try to disseminate the knowledge to these different stakeholders by imparting trainings, and also the lessons that we have learned. So yes, I hope I have answered to this question. And second, the third part, which is most important, is that, the test bed which I was mentioning, already, these test beds are further, taken to demonstrate the real-time model. And once these are the results are verified with the quantifiable and measurable, then definitely these will act as a model for others to follow, right? So this is, thank you.
Thank you. So I think apart from scaling up and having all the stakeholders in buildings take up these new technologies, I feel cities also play an important role. And Professor Lang, you have been also in your research been focusing on how to institutionalize climate change mitigation and adaptation through city advisory committees. I feel that cities can also, through the right policies, make sure that sustainable buildings, the full potential can be leveraged. Maybe, Professor Lang, you can show or demonstrate which policies cities would need to adopt to make these sustainable building practices more, to leverage the potential they offer.
So, I mean, the issue of communication was mentioned before by Mr. Kumar, and that's the same thing. So typically people would only talk about climate protection, meaning mitigation, right? So you would have whole units who would do every day nothing but really look into better thermal insulation, use of renewable energies, and so on. Fine. Then you have other departments where they only do adaptation. They only look into the green. There's landscape architects. There's also people who can use the relevant tools to simulate outdoor comfort, and even, make a connection to indoor comfort. So these typically two different worlds. And what you see is they're fighting for money. There's only a certain amount given, you might spend on a housing project or on an urban development project. And so they're fighting for this money. And they're basically fighting each other instead of coming together. So we have a PhD who was running for the last 4 years. Actually, they're presenting his results next week. And it clearly showed with an analysis of a tremendous amount of cities, which cities had which structure. And it was really those cities who had unified offices where both parties were involved, who were the most successful ones in implementing structures for basically doing climate change mitigation and adaptation at the same time. And that's the way we have to go. We have to bring all these entities together so they're really pulling on one string in order to get things done. And that's happening in some cities already. In other cities, they're not even aware of the importance of doing things in parallel together. So that's really key with regard to policy making. We are doing a project right now together with the City of Environmental Affairs and the City of the building department, the ministry, I should say, sorry. We are doing this with about 12 cities in Bavaria, where both ministries are working together, and we are coordinating that at the chair, so that basically really climate change and climate protection and climate change adaptation are thought together in real housing projects, really to implement that. So you have the policy side and the implementation where you have to bring together. And in the end, if you raise the awareness, it's not that difficult.
Great, thank you. I feel like for the implementation, green rating systems might help. As I had mentioned in the introduction, I'm working with the DGNB, the German Sustainable Building Council, and we have, for example, set up the DGNB system, which is like a sustainability benchmark for buildings in different life cycles. And Dr. Schwede, you've already, as a director of an engineering company, you've also had experience with certifying projects in China and Thailand. Those were the first DGNB projects actually in those countries. How can sustainable rating schemes help in implementing the green building objectives we have?
Thank you for this question. Really, we were involved in the first DGNB projects in China. It was 2010 already, I think, the first deep project in China, and we did several projects now in Thailand as well with my colleague Robert Himmler. He is working there on the ground. Of course, we also apply other certification schemes. In my feeling, it is very important that we have front runners in the market who are able and willing and have the potential to create buildings which are better than what is the mainstream building. And for that, certification schemes are very important so that we can demonstrate, that we can test technologies, that we can test also assessment approaches in these markets. If I talk again about the market in Vietnam, there we have our own local certification scheme, the Lotus scheme, which is very well adapted to the situation there. And there, I have the feeling that the certification scheme developed by, let's say, NGO type of organization is testing the market. They are faster than the government. Of course, the ministry may have a lot of consultation, a lot of decision procedures and so on. They cannot change their requirements so fast, but with private and semi-private certification schemes, we can set up some criteria, some requirements for buildings which can be tested in the market much faster. We can set topics which then are discussed by the stakeholders, by the researchers, but also by the practitioners. And that is very, very important. I would not say that we have to have a broad, holistic assessment for sustainable building in all countries on as a requirement, because we can't put too much requirements on the normal market. But for front runners, this is very important to implement that. And that is also possible because there are always people who have the means to go further, who have the capacities, and they are giving examples for the other market stakeholders. That is very, very important.
Thank you. We have another question for you, Professor Lang, from the chat. How do you see circularity and net zero being a reality in the construction sector globally? And what would you see are the immediate challenges for circularity and net zero?
Yeah, thank you very much for the question. I think there's really good news there because, let's say, if you look at our own nation here in Germany, we see that there is a shift already happening. So we have actually construction companies who have focused on the destruction of buildings before, so they were really just tearing buildings down and tried to get rid of the rubble somehow. They are now establishing business models where they're really looking into circularity in the sense of really doing recycling, not a downcycling, but a real recycling of materials based on the economic situation. In Bavaria, we are not allowed to build any kind of waste dumps anymore. So we have a real pressure on the whole building business in order to find solutions to either get rid of the construction material of a deconstructed building and to sell it to other countries, to Czechoslovakia, to Poland, or they try to really capture the value in the material in order to sell it. And that's happening that's happening right now here in Germany and also in other countries, in Switzerland, in the Netherlands, which is an advanced country in that field. So we get it started. And the key is really to look into the real value of material and the real damage done by waste. That means basically the carbon emissions which are embedded in the material. We have to really evaluate that in the sense of the damage done to our environment. And we have to understand that our environment is the base of our living. So in the end, a kind of a penalty system and a kind of an incentive system come together, where on the one hand, we are supporting the use of recycled materials, and we will see that coming in the immediate future right now. And on the other hand, to really evaluate and value the damage done to nature. So the 25 euros per ton of CO2 we are emitting in the building business, where materials have to be counted in also. That's not enough. We have our ministry, the Federal Ministry of Environmental Affairs. They go depending on how you calculate the damage, it has to be at least 168, almost 170 euros per ton of CO2. That's the minimum. And we are at 25 right now. So the answer is to really find ways to use the material again and to penalize the production of waste. And it can be done. We are full of regulations in Germany. People hate regulations here. They fight, let's say, carbon taxes and so on, but it's ongoing due to European pressure. So at least for Europe, I can say that we're going to see a shift coming very soon, not very soon, meaning in 20 years, but meaning right now. It has started already. So that might be a way to go for other countries also.
Dr. Schwede, I think you wanted to add to this question as well.
Thank you for giving me the chance. I would like to add to what Professor Lang just said from the international perspective. In the projects we are doing in Vietnam and also the project in Cambodia, we wanted first to talk about energy efficiency and these kind of issues, but our colleagues came and said, no, we want to talk about materials. We want to talk about recycling, because these are pressing issues in our country. We know that, for example, Mekong River is destroyed by sand excavation, and how can we use recycled material to replace that, and so on. So the topics are there, they are discussed, and it would make sense to look into these countries, into these discussions, also to learn something perhaps for Germany, and at least to exchange on the different solutions. I wanted to say and express that the topics of circular economy are in the discussions. They are at the universities, but also at the ministry level. From my experience, it is there, and perhaps we have to continue these issues and this discussion, and not only focus on our German view with energy efficiency, climate protection, and so on, but also see this circular economy issue, which is, of course, also in Germany starting and there and emerging. But all around the world, there are different topics with different weight in the discussion, and we have to bring it together. But this is also what this exchange is good for, that we see what is interest in the different situations, and material and circular economy is, from my experience, very high on the agenda in many countries at the moment.
Dr. Schwede, we have another question for you, Dr. Ashok. Actually, when we look at different pictures from cities around the globe, be it Frankfurt or Mumbai or Shanghai, we often see the same pictures, tall glass buildings, regardless of the fact whether the design fits into the local climatic context. Now, if we're looking at building materials, there was a question, Dr. Ashok, which infrastructure in India is using more circular building materials? Here there is the mention of green concrete, phase change materials, and other green building materials. Maybe Dr. Ashok, you can elaborate on what kind of projects are using recyclable or sustainable building materials.
Thank you. This is a very good question. There are several attempts going on in the country, not only for developing the use of or using these phase change materials or using green building technologies. In India, if I talk about, there are several examples where several technologies developed by CBRI have been used in buildings, particularly in the housing sector. So, starting from the AAC block, autoclave aerated concrete block, which is where we use the waste from the industry, steel industry, and try to develop these materials, and where the attempt is that we can reduce the thermal conductivity of the material, and if we are reducing the thermal conductivity of the material, it will further lead to reduction in the overall heat transfer coefficient. So this is number one. The second point which he is asking is about the phase change material. Yes, in India, if I talk about, I'm not talking about other countries, but I can cite one example that yes, there are attempts going on where we can tune the phase change material. You set the temperature that yes, we want to use the material, say in Mumbai or in Delhi. You can tune that PCM depending upon the climate conditions that we have in these cities. For similar examples can be seen in other countries as well. So this is number two. Number three is that yes, about the green concrete, the attempts are going on, and people talk about cement-free concrete, where geopolymer concrete is one of the solutions, and where yes, again, CBRI and other CSIR laboratories are coming out with options that yes, there is a concrete which is cement-free concrete, and where the fly ash content is more, and we at CBRI is trying to showcase one building where I think it's going to be 100% geopolymer. All that components, be it walling component or the columns, the beams, slabs, everything is geopolymer concrete. So I think yes, there is a lot of research going on, and if I talk about in the coming years, all these green technologies will definitely find a good market. If I talk about next say 3, 4, 5 years, but at the same time, as I mentioned in my talk, all those results have to be quantified, they have to be measured and verifiable. So that means technology readiness level has to be at 9 or 8 level, so that we are sure that these alternatives or green solutions are going to rule the world, or are good for the countries like India and other countries as well. Thank you. Hope I have been able to answer the question posed by Mr. Dibyam Saran, I think.
Thank you. I think we have time for one last question. Professor Lang, in your presentation, you had mentioned the concept of sufficiency, consistency, and efficiency. I find that super interesting, and I would like to know from you, how can cities focus more on sufficiency when building, and what would project developers need to add to incorporate this guiding principle into new projects?
I think the question is really good to really look at the city on a scale. You know, it's our personal behavior. Typically, you know, do we need a car? Do we go by bike and stuff like that? But on a city scale, we really have a much higher potential in order to do the planning accordingly. So I've mentioned already mobility as an issue. You know, do I design a city which is meant for bicycle users, which is meant for pedestrians, where I do have streets which are well shaded, which are offering a lot of quality to pedestrians and to bicycle riders? Or do I design a city for the car use, which we have done in the 60s and the 70s, and the results we see not only here in Germany, we see it globally. So let's say the mobility sector is a really key issue, because another 1/3 of the CO2 emission go really to mobility. So that's a really fast fix eventually. I mean, we are a car-driven society here in Germany with all the car producers we are having, but we see that shift already happening. The other thing is really the building sector as such, where we have to really stop single-family homes along the outskirts of the major cities. We really have to use the space there in a more meaningful way by leaving much more space for the green, much more space for the open, much more space for relaxing, and being more concentrated with our buildings, still looking into high quality of the buildings, but really not waste that much of open area on the one hand. So that has to stop. And it can be stopped really, even with a growing city. There's options to densify cities. And the other one, if we have more compact buildings, we also have less space to heat, less space to cool, and we can still have a high standard of living with all that waste of materials. So I think these are two of the examples where city planning governance play a major role for sufficiency.
Great. Thank you very much for this very interesting answer. As a last point, with a look on the clock, I realize we have to end this interesting discussion we had. On behalf of the DWIH New Delhi, I would like to sincerely thank all panelists and also our audience for the questions and attention you had. We've learned that there are already several methods available to implement green sustainable buildings, and there are still very interesting research projects which can be had: circularity of building materials, research into how city advisory structures could change. But what we require in reality is the exhaustive implementation of all these practices. So before I say goodbye to you, I'd like to point out the next two program points. We have another panel session. There will be two parallel sessions. One is on air quality in cities and the other one on coastal cities and climate change. And in case you want to take a break from the panel discussion, I'd also like to invite you to just join the virtual fair the forum is offering. There we have 25 international research institutions with booths and a special networking launch. So thank you very much, and we will be ending this panel discussion.
Thank you very much.
Thank you. Bye. All the best.
Thank you.
Thank you very much. Bye-bye.